Hello, Assalamu alaikum. My name is Fakisha, and in this video, we will be doing simplification of Boolean function by using K-map or Karnaugh map technology. So, first of all, we will discuss what's Karnaugh map. So, in introduction, Karnaugh map technology was invented by Maurice Karnaugh back in 1953 in Bell Lab. A K-map is a matrix consisting of rows and columns that represent that output value of a Boolean function. The output values placed in each cell are derived from minterms of a Boolean function. So what are the minterms and what are SOPs? We will be discussing further by seeing the truth table. So here we have four inputs that are A, B, C, and D, and one output. So here we have to make a function so which can represent the one. So by using SOPs, that is sum of product, we will construct the formula. So here you can see that this first term, that f is equal to conjugate or inverse of A into B, which is into C, inverse of C, and D. So here for the first, when the output is 1, we will see that when the input is 0, we will write inverse of that input. Over here we have A, so inverse of A, we will consider inverse of A, and for B it's 1, so B is 1, so we will write B only, and when it's 0, C is 0, we will write inverse of C and into D. So here we are following the technique of sum of product. So first of all we were doing product of every entry, and then we are adding or doing sum with the second entry. So it becomes sum of product. So it's the sum of the products. So for the second entry we are using this, here will come inverse of A, and then B, C, D are 1, so we will write B, C, D. It's this A inverse and B, C, D. And in the similar way we are doing these, for these 8 ones output we are writing this equation. So what is the importance of this K-map technology? So it simplifies this whole large formula into less entries. So, so here you can see, with the help of K-map, I've constructed this table, and the formula for this output that we are getting from this table, and we have made this whole large equation for it. This can be reduced to this only BD plus inverse of B into A by using K-map technology. So how we have made this table, we will see that for 0 0 in here we had, in the y column, that is in the vertical column, we are having, we are taking A and B inputs, and in the horizontal column we are taking C and D inputs. So over here you can see, for here we have 0 0, that is C and D are 0 0 in the first column, and in the second column we have 0 1, that is, we are taking C as 0 and D as 1, and in the next one we are using 1 1. Next column is 1 1, that is C and D both are 1, and the fourth column we have this C as 1 and D as 0. So in the vertical section we are having 0 0 for the row, that is and A and B are 0, and in the second one we are having 0 1, and in the similar way 1 1 and 1 0. So by seeing our previous table, we have that according to this 0 1 and 0 0 and 0 1 0 1, we have placed these ones output in this table, and we have made the group according to the 2 and formula. That is, we can make the group of 2s, 4s, and similar way we can increase according to the 2 and formula. So here I've made this group of 4 over here and a group of 4 over here, and this all reduces to this formula. So we will prove this, either this equation or that we have made from Karnaugh map holds and satisfies this previous equation that we have made without simplification in Proteus. So we will shift on to the Proteus. So here you can see We have the bigger circuit without simplification. I will run the simulation. So here you can see when our output is 0 when all the inputs are 0. From the table you can see when inputs are 0, our output is 0. But we will see for the ones because we are constructing this equation for the ones output. So when we have inverse of A is on and inverse of C is on, so it's corresponding to this 0 1 0 1, we are having output 1. Similarly, for the second one, that is A inverse BCD, so we will reviewing this. So here A inverse BCD, so it's still satisfying, that is 1. We will do, that is we will make 0, and we will make B, C and D on. We will have 1 on the output, that is B, C and D on the 1 output. So in this way it is satisfying our equations. Now the circuit we have made with the help of K-map, here it is, and we will satisfy this equation. So I will run the simulation. So for making it on, we will switch on this BD, B and D. So you can see our output is 1. And in a similar way, when B inverse and A is on, it is B inverse and A is on, we are having 1. So when B inverse and A is on, we are having 1. So in the next video, we will implementing these equations in quarters. So by making the Verilog HDL code, so you can see in the link above.